Today we are doing lesson 8.4 on multiple representations of functions. So our worm is on page 603. We see this. Now, for the number of friends, it costs $9. Each friend must pay an admission price of $9. We see that up at the top. So how much do 2 friends pay?
18.
Gloria!
Number 1.
Perfect. We get 18. We all know our nines table. 27. 36. We graph this. It approximately looks like, that. It makes a line. Shocking, because we are learning about linear functions. Describe the graph. Line. So, write an equation to find the cost of n tickets. Who has an equation? I want to see. Daniel, what's your equation?
N equals
N. Perfect. So it would be 9n. The reason we're using that word n here is because it's the cost of n tickets, and we don't know how many tickets we're going to buy. Each ticket is $9, so we multiply it by 9. We buy 10 tickets. It costs us $90. If I plugged in 10 for n, I would get $90. List the ordered pair when 5 friends go to the museum. When 5 friends go to the museum, it's gonna cost $45. We all know our nines. It's as simple as that. And notice, if I plugged in 5 for my n, what am I gonna get? That 45. 9 times 5 is 45. So I want you to write this one in your notebooks. A runner's distance in a marathon is equal to 8 miles an hour times the number of hours. Write the equation. Okay, Daniel, what did you get as your equation? 8h. Perfect. 8h is our distance. 8h is our distance. Makes sense. 8 miles an hour times, we literally see that word, the number of hours. The number of hours is our unknown. He picked h. Perfect. Great job. It's really not that hard to turn words into numbers when you search for those key words. We search for the operations. We search for the numbers. We search for all of that. So, how about this one? You don't have to copy this one down necessarily, but Drama Club is holding a bake sale. They charge $5 per pie. If T is the total earned and P is the pies sold, we would have total equals, and who can tell me? Let's see, Lucy. Yeah, 5P. Great job. Once again, we see this. They charge $5 per. That means each. We see that. So, in science, Mia finds that the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths B in a non-active person in m minutes. Who can tell me what this equation would be, Gloria?
B equals 14m.
B equals 14m. At this point, it's just reading the problem, figuring out what the operation is, typically multiplication, but not always. And then we see this. Now, on page 604, do A and B. So, a mouse can travel 8 miles an hour. What is the total distance a mouse can travel in h hours? Rocco. Perfect. D equals 8h. 8h equals D. Either way. Alinza. Samantha can make 36 cookies each hour. How many cookies can she make in h hours? Perfect. C equals 36. H for the number of hours that she bakes. Excellent. Now, sometimes you'll see different forms. And we saw this last night on our homework. You might see the word problem. You might be given a table and or a graph, but we're going to see the multiple representations that we would get from this word problem. Student council charges $7 for each car they wash. What is the equation, Gore? Perfect. So it's equal to 7C, where you're going to say, I'm going to put the money sign. So the total dollars they get is equal to 7C. Excellent. Excellent. So if they wash 0, 1, 2, 3 cars, we plug it in. If they wash 0 cars, how much money do they make, Romario? Nothing. Whopping $0. If they wash 1 car, how much money do they make, Andrew?
7.
Perfect. $7. Emerson, if they wash 2 cars. 14. Melanie, if they wash 3 cars. Perfect. Now, for 1, for 0, we get 0. 7, 14, 21. It makes a nice line. Do we see that? So you might be given a graph. You might be given a table. You might be given an equation. You might be given a word problem. All of these are synonymous. All of these are synonymous. If we were given the table, we see here we've got an increase of 1, and here we've got an increase of 7. That tells us our slope, our coefficient, the number in front of our variable, is going to be 7, because we're adding 7 each time. And we know if we were given the table that we don't have anything addition afterwards or subtraction afterwards, because when we plug in our numbers, they work each time. 0, 7, 14, 21. Same thing would happen here. We're going up 1 each time. We're going up 7 each time. This is a literal slope. That's a literal slope. That's how slope works. So our slope would be 7.
That's what M works.
So all of these are the same way to see a different problem, or the same way to see the same problem, just different ways. Now, you must show me before you go on. You got to do page 606, C, D, and then on the back side, I believe, or no, then there's number 1, A, B, and C for the guided practice. So before you go on, you must show me. Rocco, what is the equation that you get? Malia, what'd you get?
30H equals D.
Perfect. 30H equals D. That's the distance is equal to 30 miles times the number of hours that they fly. So in 1 hour, they fly 30 miles, right? We plug that in. In 0, it's 0. In 1, it's 30. In 2, it's 60. And then in 3, it's 90. Look, it forms our nice little line. Essentially, if you're not getting a line, you're doing it wrong. Now, yes.
If we did Y,
Daniel asked, we graph the ordered pairs, right? Yes. H is our X because it's right there. And it is our independent variable. His distance is dependent on the number of hours that he flies. Our dependent variable is our Y. That is our dependent variable. Because we want to know why. Then that depends. I don't know. So here, the school cafeteria sells lunch passes that allow students to purchase any number of lunches in advance for $3 per lunch. So what would the equation be then? Romario. Lucy. Perfect. T, our total cost, is equal to 3N. Excellent. Now make a function to show the relationship between the number of lunches N and the cost T. Elsie asked earlier, does it matter which numbers we pick? No, I'm going to pick 2, 6, and 9. Just for funsies. Actually, 9 is not, they're going to go too high. 2, 3, and 4, because then they can fit on my graph, kind of. So, for 2, I just plug it in. All I'm doing is plugging it in. 2 times 3 is 6. We get 9. We get 12, which isn't going to fit on my graph, but that's fine. 4, we're up here, it's 12. 3, we're right there, it's 9. 2, we're right there, it's 6. Look at that nice line that we made. Analyze the graph. It is a line. So your homework is page 607. Numbers 1 through 3. It does go on to the back side. Numbers 1 through 3. For the homework, one of the things the problem did not make clear is that the online fee is per ticket. The online fee is per ticket. So this graph that we're looking at here is a really bad looking graph. So, for example, 2 tickets were $24.95 each. So how much did he spend for 2 tickets? Rocco?
$49.90.
Excellent, $49.90. But we have to pay an online fee.
80 cents. 80? No.
It's 90.
We have to pay an online fee, but that's per, we have an online fee per ticket. So we've got 2 tickets times the fee. Each fee is per ticket, so we've got 2 times the fee, just for this specific equation, just for this one. 2 times the fee, and we find that that total is $64.50. When we solve this problem, I want to remind you guys that we show our work with the reverse PEMDAS. So first thing we do is we're going to subtract that $49.90 from each side. That's going to go away. We get 2F is going to be equal to is $14.60. Then we have to divide each side by 2. We get the fee equal to $7.30 per ticket. The fee is equal to $7.30 per ticket. It asks you to solve it. That is part B. That is part B. And then another friend wants to go to the concert.
Okay.
What is the cost of ordering 3 tickets? We have 3 times $24.95 plus 3 times our fee, and we're going to get our answer.